It's my pleasure to welcome you all to this international symposium. I'm Mahshid Tutunchi, lecturer at the School of Project Management, Uni of Sydney. I would like to acknowledge the people of Eugera as I'm in Brisbane. Please feel free to participate and use the chat to ask questions. The focus of this session is on projects as interventions to achieve net zero. Coping with climate changes requires dynamic planning for efficient use of existing infrastructure, smart integration of new technology, and balancing economic growth with social sustainability. Projects as sudden or modular interventions facilitate the optimization of supply chains and operations planning. I would like to introduce our three distinguished speakers. Our first valued speaker is Professor Giorgio Lucatelli from Polytechnic University of Milan, Italy. Giorgio, thank you so much for joining us. Would you mind to introduce your research?
Yes, thank you very much, Mahshid, for the invitation and organizing this. Really appreciated. My name is Giorgio Lucatelli. I'm a full professor of complex project business in the Politecnico di Milano. My interest is toward net zero and the role played by infrastructure and project in net zero. I'm looking at this with my PhD student, Marco Terenzi, which is also in the room, and people is welcome to connect with him. And we are very pleased to be here today.
Thank you so much. We are very pleased to have you here. Our second valued speaker is Professor Ali Abbas, Head of the School of Chemical Engineering, University of Sydney. Ali, it's our great pleasure to have you here. Would you mind to introduce your recent work?
Hi, Mahshid, and good evening, everyone. I'm Ali Abbas. I'm acting head of School of Chemical Engineering at the University of Sydney. And I work in an area that is called process systems engineering, where I apply systems thinking to solving problems in the domains of clean energy, low emissions technologies, and also circular economy. I'm very pleased to be with you today.
Thank you so much. It's an honor for us. And our third speaker is Professor Daniel Armanius from Saïd Business School, University of Oxford, UK. Daniel, it's a great pleasure for us to have you today. Would you mind to introduce your recent research?
Thanks, Mahshid, and a pleasure to join you all and be amongst these distinguished panelists. I'm the BT Professor of Major Program Management at Saïd Business School. It's the best way to understand my research. It's civil engineering meets organizational sociology. So I'm interested in how organizations interact to underpin various systems, ranging from innovation systems all the way to broadband and water, and how that works amidst complexity and disruptions that we will increasingly face in the future, of which one of them is environmental and climate change. Thank you so much.
Fantastic, thank you. Giorgio, considering the limited time frame for reduction of emissions by 2030, how do you think that projects can act as interventions to achieve net zero?
Yes, I think that projects are vector of change, not agent of change, because the agent are people. So projects are vector of change. And there is no such things as a net zero project, because when we do a project, we have a contribution in terms of CO2. However, what I think is that the project can transform assets that emit CO2. And basically, project, I think, that can do four different things. One is to create a new asset. So, for instance, replace a coal power plant with wind. They can upgrade existing asset. So, for instance, all the work done in housing retrofitting, or in general building retrofitting. This is an example of upgrading existing asset. Or they can have intangible outcomes. So for instance, how we use the asset, convince people to decrease the temperature in the home and put a jumper instead of turning the heating on. And lastly, the last category is R&D project. So project to develop asset that in the future will reduce CO2 emission. For instance, developing a fusion project. So project can change the asset, or even better, can change the portfolio of asset. And we can apply this to different sectors. Let's make an example. Let's think about the aerospace sector, which belongs to transportation, which is a relevant contributor to CO2 emission. So in this case, a project can do two things. So one, we can have a project to reduce intensity. So the idea that we have aircraft which are more efficient for the same amount of kilometer traveled, we have less CO2 emission. This can be an R&D project. Or, and that's the second axis, we can reduce quantity. So reduce the number of kilometers that people have to travel. And this can be done, for instance, through behavioral change project, as we did historically for smoking. So we have a project to reduce smoking. We can have a project to reduce the quantity of miles that are flight every year by people. So these are my idea of how project can be intervention and vector of change toward net zero.
Fantastic points, and it drives my mind to Ali's recent research. Ali, how do you evaluate integration of existing projects with, brown and green fields? It's very hard to integrate the new technologies to the existing one, considering different aspects of projects.
Yeah, that is an important aspect of projects. I guess I start off in my thinking about projects using the systems approach, the systems thinking. That's kind of a basis for all sorts of ways of dealing with net zero problems, circular economy problems, and other systems as well. So these systems of thinking approach can be used to tackle industrial projects, especially when we think about scale. I think it's important always to understand the scale, and many of these projects that I work with are larger scale, sometimes mega projects, and trying to understand how they play out in terms of the environmental impact is quite important for me and for our research. So we often focus on the emissions aspects of these projects and the emissions related to the output from these projects. So industrial ecology for us is one of those areas that we have in the last few years been focusing on, trying to extend beyond the existing body of knowledge of industrial ecology, industrial symbiosis, and trying to think about that scale I'm talking about and how we can integrate plants together, manufacturing plants, that is, because what we've discovered through the research that the future for net zero is going to see less and less operation at standalone level, meaning that plants or manufacturing facilities that work alone will not survive in the future. So this symbiosis between plants becomes extremely a necessity for profitability, but also for achieving quite significant emissions reductions. Industrial systems, if they are integrated together, and if we have the opportunity, and coming back to your question, Mahshid, about greenfield versus brownfield, if we have that opportunity to start with a greenfield design of such operations, we can capture and leapfrog significant emissions mitigations. And that is because waste from one operator can become the resource and feedstock for the other operator. Our research has shown significant emissions reductions if this is done via computational methods, via smart ways to design, and of course you can then move into the smart way to operate these facilities. And that's kind of the intervention I try to make using that systems thinking, that scale, the integration through industrial ecology, and monitoring and accounting the emissions all the way in all those steps.
And thank you so much. Do you think that the same system thinking applies to circular economies, especially their effects in sustainable systems?
The transition to circular economy systems and circular economy project is harder, is more difficult. There are many reasons why that is. We can, at the moment, begin to think about the circular economy or the true circular economy, which looks at designing or eliminating out waste completely. and also keeping the resources in circulation in the economy for longer. So those kind of principles, as well as the regeneration principle, all of those principles are now being worked on by many researchers around the world, trying to understand how to measure the impact of the circular economy. And so it is still unclear to many how that impact will play out in the circular economy projects. However, what we want to move forward is beyond these kind of metrics around diversion from landfill, for example, that traditional metric. We want to start moving into circularity metrics and starting to design around those, what I call the socio-economic metrics and objectives. Once we understand that a little bit more, and that's happening, we can begin to create that circular economy intervention in projects.
Fantastic. Thank you so much. Daniel, my question in regards to your recent research is in terms of different scenarios that projects can run to achieve net zeros. How do you evaluate those different scenarios, considering what Giorgio mentioned about the projects for net zero and what Ali mentioned about integration of greenfield and brownfield? Your research directs these two conversations.
Yeah, thanks, Masha, for that question around scenarios. I think the way I think of it around scenarios is thinking around what the scenario is trying to instill. So I kind of think of three things at the moment, especially as they relate to net zero. One is kind of scenarios around new technology, either for delivery or facilitating new thinking. And I'll get into that in a minute. Second is new organizing norms. What is these new kind of future scenarios around environment going to require in terms of organizing even a project? And then third, the scenarios, are we paying attention to marginalization, new stakeholders? So to kind of quickly get into this, if you look at new technologies on the delivery side, you're seeing a rapid increase in automation and printing. So for example, right now, the Chinese are proposing the Yangzhou Dam, which they plan to 3D print in 2 years. And it'll build the largest 3D printing machine that we've seen. And if we see that trajectory go forward, where machines are printing out your technologies, there's scenarios now where you could automate repairs because the machine has developed where the screw is, where the bolt is, etc. But it also makes us even have to be more acute to bias, to attending to bias. And we can get into that later in the discussion. On new technologies around kind of thinking about how do we think in this new kind of future world around net zero, I think what's fascinating about major projects, major programs is the notion of collapsed timescales. So we have to have emissions by 2030. We have to hit net zero by 2050. The average major project takes 5, 10, even upwards 15 years. So essentially what that means is whatever project is being conceived now has to develop immediately at least half emissions right away, just from the deployment. Now, the challenge with that is we know that the climate's warming. We know that there's more climate change, but it's also more unpredictable. It's more torrential rain, more infrequent kind of temperature changes. And so now you're asking a major project manager to anticipate, what is flooding going to look like on my bridge 10 years from now, 5 years from now? What is temperature going to do to my server management system for my cloud computing? Right. So how do you kind of build that? That's now bringing a whole line of technologies that we see around augmented reality, virtual reality, to at least give people the best possible scenarios we have, and then try to think, how can that help maybe develop anticipatory heuristics? I think it's an exciting area of research, and I think it's still really early. In terms of new organizing norms, I think what net zero particularly is requiring is we think more distributed and not mega. Now, why do I say this? Let's just take a couple of examples. Let's look at cement. Cement is 8% of global emissions. There's different grades, there's different needs of cement, different porosity, different reinforcement, and all of these are around a whole portfolio of projects. It's not just one centralized project that's running a lot of cement, let's say. Transportation, 24% of our global CO2 emissions, again, very distributed, hub and spoke. High-speed rail in the UK is going to look very different than Australia. It's going to look very different than in Rwanda. And I think what we're dealing with then is not a convening site of a bunch of centralized mega projects, but a distributed portfolio of projects. And I don't think we really have good frameworks to understand major programs as portfolios as opposed to centralized mega projects. And that requires replicating means as opposed to the ends. It requires situating those methods in different locations. And then the final one, I would say, we need to have scenarios that include historically marginalized stakeholders. So if we're thinking of improving not just the delivery outcomes of major programs, but their resilience to environmental change and ways to get net zero, we now have to start thinking about strengthening our most vulnerable populations, because they're the first and foremost that are going to be hitting the front lines of climate change. And we need to be able to equip them to be able to handle those immediately on site, as opposed to waiting for the disruption to propagate. And that requires really new thinking about how we co-design and co-govern major projects or mega projects, whatever term you want to use, with marginalized communities that are often experiencing the brunt of the environmental degradation immediately. And it also gives us kind of an early warning system of how to rethink risk, rethink our deployment of projects in light of those marginalizations. So just to summarize, we need scenarios that incorporate new technology at delivery, as well as facilitate new anticipatory thinking on an uncertain future. Second, new organizational norms that are thinking of projects more distributed as opposed to centralized mega projects. And then also these scenarios need to include new stakeholders we haven't included historically.
Fantastic. Considering this multi-objective nature of net zero projects, assessing risk would be really challenging. And something that I got from your paper is environmental interruption as a possible risk. So because these scenarios should be dynamic live, do you see the role of AI in future scenario planning for net zero projects?
Yes, I do. Whether we like it or not, it is going to become much more ubiquitous. We're seeing algorithms right now developing all sorts of decision making. I mean, I even heard, won't mention the company, even AI is now deciding bonuses for managers automatically without any human intervention. I think there's a couple of things we have to keep in mind. One is, if we understand how these algorithms work with assessing risk, we may have to think of it more processually. I know Jennifer Wyatt, Andrew Davies, Nuno have all been doing these kind of things, thinking not just at the planning phase, but through the whole process. The other key thing is thinking about how risk propagates. So usually we think about it from the single project, but if they're interconnected portfolios now, you have to think if risk accumulates in one project, it's going to propagate into another. So even thinking of kind of risk propagation methods and how to do it, but also attending to the bias. I mean, especially when we're dealing with marginalization, we historically don't have data on those kind of communities. And if we're using AI to assess risk on essentially an out sample, there's a lot of danger with that if it's not grounded in the same arena as the training data. So I think it presents really interesting, cool opportunities, but also some really important biases and harms that we have to be attentive to even more acutely than we are historically.
Fantastic point. And again, another risk that I love to read in Giorgio's paper was assessing consumer behavior in our planning. I can see that you foresee these changes in consumer behavior affecting our planning for net zero. Would you mind to explain more?
Yes. Firstly, we have to understand that there is a new idea, a new framework to look at consumer behavior and how consumer behavior shapes infrastructure and shapes project. This is called system of provision. Is something that has been developed by unorthodox economics and is truly interesting to see this from a project management point of view. And I can make a simple example, okay? So I'm based in the north of Italy. North of Italy during winter is quite cold. We have to heat our house, okay? Now, if we decrease by 1 degree the indoor house temperature, we can save 3.5% of national gas consumption in Italy, natural gas consumption in Italy, which is a lot because Italy uses a lot of natural gas to make electricity. Now, so if you decrease by 3 degrees, you cut natural gas consumption by 10%. Decrease 3 degree temperature at home means to convince people to put the jumper on. Okay, so an extra layer, That's it. No technology, and this pains me to say because I'm a mechanical engineer by background. So the big question for me is which kind of project can we do to convince people to reduce a bit the temperature at home and put an extra layer on them? Okay. And I feel that is missing a chapter in our project management book. So if I look at the books that I used to teach my students, they speak about infrastructure, they speak about scope management, they speak all about this, but I see there is a kind of bias toward hard project to build an house, retrofitting or whatever. So what we want to look at is what I call intangible project. So decrease the temperature, how convince people to decrease the temperature at home, I have convinced people to fly less, and so far and so forth. And so when we look at these, we have a new kind of, for instance, innovation. And it's not the traditional innovation that comes into place when you discuss a nuclear power plant. That was been my topic for 15 years now, because there is no test to run, there is no material to qualify or something like that. And this is super important. And the last point that I want to make of this is that these need to fit in a bigger scheme that we believe is the national decarbonization portfolio of project. That of course include hard and traditional project, replace coal with wind or nuclear, okay? Sure, but is far more than that. And this layer of complexity that makes a mega project, building wind farm and nuclear power plant, with a super simple project, convincing people to isolate the roof or decrease the temperature at home, create a network of complexity and a network of incentive between stakeholders, which is incredibly complex, but also incredibly interesting to research.
Amazing point. We really have to consider different type of projects. Ali, there is a question that has been raised, and I guess it's very relevant to your work. When we talk about net zero, generally we think about solar panels and wind power, very clear, clean, and peaceful. What other sources of energy would you consider, and what other type of projects to achieve net zero shall be considered besides just the clean electrical power?
Yes, Mahshid. I guess the point that you raise here is important, and I'm very happy to share some of the insights from our research on solar panels. We look at solar panels as a renewable green technology that can solve a lot of the problems around energy and the energy transition for net zero. However, it is starting to emerge more and more and becoming common conversation that there is this energy and material nexus. So we cannot just solve the problem by looking at the transition or the energy transition problem by looking at renewable energy and energy alone. We've got to think about the material intensity of every energy unit that we produce. So if we are producing it from solar panel systems, this solar panel has many, many types of materials embedded in that panel, which then lets you drill deeper into it. You find metals such as aluminium, copper, even lead, and other such metals used to manufacture such a product, such a technology. So kind of, when we start to roll out massive projects such as solar farms, or as we have in Australia, solar panels on rooftops, we are the leading country in the world with solar panel penetration on rooftops. More than 30% of homes have solar panels now. And my estimate says that there is about 54 million panels on rooftops now in Australia, and it's going up ever so fast. And that means that we are coming to a situation in the next few years where we will have a massive stockpile of materials. These end-of-life solar panels that we will need to pull off the roofs and maintain, or simply start to think about recycling them. Therefore, one needs to think about the energy delivery, this functional unit that we can call 1 kilowatt hour, along with this material use? This is kind of this question you raised earlier about circular economy as well, this
Exactly.
material energy nexus. And so this functional unit is very important. And Giorgio mentioned the point about this temperature control in Europe and the efficiency improvement that can bring about if we just reduce temperature by 1 degree Celsius. Well, we need to start thinking differently rather than falling in trends. And I call the solar panels a big trend. I'm not against renewables. Please don't quote me in that way. I'm all for renewables. However, I'm all for designing these renewable technologies in better ways, or even better, designing for the functional unit, which is that 1 kilowatt hour, which means, back to Giorgio's example, which was a good one. Well, we probably in Australia, we spend and lose a lot of energy because our homes are not well insulated. So simple insulation measures will create that efficiency improvement that we need. And that's that project that we need to attack rather than deliver more and more supply of energy. And that is driven by profit. So we want to be selling more of that product as we go forward. So we've got to think differently. We've got to think smarter about that problem. We've got to actually define the problem more correctly, or the project more correctly, around those functional units.
You're right. Talking about net zero, it's a multifaceted, very complex strategy that needs everybody to be engaged. We have a very interesting question in the chat. Daniel, I guess it's related to you. The question is how we can convince leaders to care about intangible projects. Where you talked about community practices, it reminds me that's not just the leaders, it's everybody. How would you address this question?
So in terms of, I think it was in terms of encouraging engineering faculties, is that right?
Yes,
Yeah.
it's actually a kind of challenges of research, our contribution to the industry.
No, it's interesting. And I think this also dovetails on what Giorgio said about the intangible projects, or what I call not projects in the ground, but through the air. They're not, there's nothing physical about them. I think what's funny, because this is my first year in a business school. Historically, I was an org theorist working in a school of engineering. So historically, I was in school of engineering. This is what I was doing. And I found there was a couple of things that really helped. One is the opportunity. So right now, whether engineering companies like it or not, there's a huge drive towards behavioral and equity change at the government level. They're making it a requirement now for a lot of projects to instill. I'll give an example now in terms of, let's just cheat one of them around equity issues. There was a bridge project in Harris County, Texas, which the county there, which is around the Houston area, they decided that the bridge expansion project was asymmetrically harming the Latinx Hispanic community there. The attorney general there filed a lawsuit on civil rights grounds, basically saying that they can't continue the project unless they address this issue. And the project's been on pause for 1 to 2 years because I don't think there's an understanding on an engineering basis of how to measure equity. What's the outcomes? How far away do we go from the project? If it's a major interstate highway, maybe you have to go miles to look at that. So it's a real opportunity to develop new standards, and it's lucrative. The unfortunate reality of the Russian-Ukrainian conflict is also dealing with that because of the energy crisis in Europe. I mean, you're looking overnight 4x increase in energy. I mean, even 1 degree. I mean, we're having this discussion literally in Oxford right now, which is their energy bill is going 4x. Some colleges, just small colleges, are paying over £500,000 for energy. So if you can even reduce a degree, there's a huge opportunity in terms of money. The other thing is the repercussions. So give a couple of examples. Female crash test dummies weren't widely used until 2003. So if we're talking about even hard projects, the average height and weight of a crash test dummy that was designed for women was 5 foot, 110 pounds. The average weight biomechanically female, at least of this context, is 5 foot 4, 170 pounds. So you're using essentially a dummy that's not fit to purpose. And their implication was a study ran in the States saying that women were 73% more likely to get killed or seriously injured in a car accident. So, I mean, you see the replications immediately on engineering, and I've realized that that's driven a lot of action. And there's a book, by the way, on this, Invisible Women. I highly recommend everybody read this. It's a really good book to understand these kind of issues. So the two ways I do it is the opportunity and the new engineering techniques that need to be to address that kind of social reality, and also the repercussions for not doing so. And I think companies, especially now, are really hesitant, especially engineering construction companies, are really hesitant and really worried about being on the wrong side of this. And so that, I think that's driven a lot of incentive. I've seen big movement in engineering faculties now to have organizational folks, engineering management programs, really because of some of these issues. So I think that's the kind of ways I've found has actually been useful and been able to get grant funding even to try to do this work.
Fantastic. Beside all these economic behavioral facts, we as scholars have lots of challenges to implement the projects, get the fund, and run the projects. Giorgio, what huge challenges do you see for scholars to define net zero projects?
For me, the huge challenge is collaboration. So we need to learn how to speak to each other, because we, as project scholars, we historically have a very narrow collaboration, and most of this collaboration was with engineers. Most of the people in the room are engineers, lovely people, but there is far more than that. So, and you can start a collaboration with people in the legal sector, for instance. And I have something going on, and you will find that these people think in a way which is totally different from us. So they have a different conceptualization of project, different conceptualization of research, and so far and so forth. And if you speak with people, expert of behavioral change, again, they have a very different way to approach the problem. I mean, the traditional engineering system is problem setting, problem solving. Okay? Doesn't work like that. And for me, this is the biggest challenge. Opening up and be welcoming and join other community.
Fantastic. And I guess this is the challenge that we all are facing. We are trying to communicate clearly with industry and let them know what they will face in future. Something that freaks me out is if we do not plan for these very capital intensive projects, we will face high inflation rates in future. It's very close future, which affects our GDP, sorry. So this is something that we need the whole world to work on it and prevent some problems like Russia and Ukraine. Thank you so much. I really hate to end it up because I'm really enjoying this discussion. We had a very interesting discussion on challenges of achieving net zero and contribution of our research agenda to plan for a better future.